Good morning, everyone. And today we start talking about conic sections. So, conic section is exactly what it sounds like. It is a slice through a cone, or sometimes a double stacked cone like this. And in doing so, we can create these flat shapes that are either a circle, an ellipse, a parabola, or what's called a hyperbola. When we do that, we have certain things in common. So the general form of any conic section looks something like that, with the key being that to define a conic section, you either have an x squared or a y squared, and in most cases, you have both. So we're going to talk about that in a little bit. So that's what we call general form. We don't use it very much initially because to graph, we want it in what's called standard form. We'll talk about that in a minute. So in order to distinguish between your different conic sections in general form, we're going to follow these rules, and they're all based on the x squared and the y squared. So if you have a circle in general form, then the x squared and y squared will match exactly. Both the sign and the coefficient will be exactly the same. If you have an ellipse in general form, then they will have different coefficients, but exactly the same sign. So they'll both be positive or both be negative, but you'll have different coefficients on them, like 2 and 3, or anything that's not the same. Sorry, this is hard to read. For a parabola, you'll have either an x squared or a y squared, but not both. And for a hyperbola, your x squared and y squared will have opposite signs. Okay, but I told you how general form is, kind of what the conic sections will have in common, but it's not useful in terms of getting information or graphing them. To do that, we're going to put them in standard form, which means we need to complete the square. So just as a review, completing the square is a method that we use so that we can get a quadratic into a form that will factor to two matching factors. Okay. So here are the steps for doing that. So from general form, what we want to do is we want all the variables on one side, and we want all of the numbers, the constants, on the other side, because we don't use the constants in order to complete the square. Typically, we want our x squareds and y squareds to be positive as well. So if you have a circle, an ellipse, a parabola, you want the x squared and the y squared to be on whatever side is going to make them positive. With a hyperbola, since they have opposite signs, you want the positive one first. So whether it's an x squared or a y squared, but we'll talk about that more later. If there's any leading coefficient, you need to factor it out because we cannot complete the square with a leading coefficient. And that includes the negative. And then in order to complete the square, to create something that will factor into two matching factors, we take the middle term, the x term, cut that in half, and then square it. And then we add this number. That's how we complete the square. What we do to one side, we have to do to the other. So we add it to both sides, and then we factor it into matching factors. The last step would be to divide by any coefficients if we have them, if we had to factor any out in step 2, or if it's an ellipse or a hyperbola, we actually divide by the constant on the other side so that we end with 1. And again, we'll talk about that more, but jot those steps down. Okay, today we're going to specifically talk about a circle. A circle in standard form has an equation that looks like this, and this should look familiar from geometry. It is the equation of a circle that you learned from geometry, where h and k are the coordinates of the center of the circle, and this number here is your radius squared. Okay, so let's take a look at some examples. So If they give you a point that's on the circle and they give you the center of the circle, you can write the equation of the circle by doing a couple of things. You already know the center that's given to you, so you know your h and your k. What you don't know for the equation of the circle is the radius. But the radius is the distance from the center to any point on the circle, and you have both of those. So you can plug those numbers in to solve for your radius squared. So when I plug that in, I get my r squared is 58. So now I know my h, I know my k, and I know my r squared. So I just plug those in to get my equation. In order to graph a circle, you need to first get it into graphing form. So it's in general form right now. So we do that by completing the square. The first step is that we move our constant over to the other side. And then we don't have any leading coefficients that we have to worry about factoring out. So we complete the square by taking half of our x term. So in this case, that would be -3, and we square it, and that's how we got 9. So we add that here on the left side to complete the square. And what we do to one side, we have to do to the other side. So that's why it's over here as well. And we do the same thing. We complete the squares with the y's. So we take half of the y term, which is -1, and we square it, and we add that to both sides. Now that we have what are called perfect square trinomials, they will both factor to matching factors. So this becomes x minus 3 times x minus 3, which I can write as x minus 3 squared. And similarly, this factors to y minus 1 squared. And when I clean these numbers up over here, I get 4. So I can see that my center now is at the 0.31 with a radius of 2. Remember, this is the r squared, not the radius itself. So you can graph it by plotting the center and then counting from your center up, down, left, and right the length of the radius and trying to make as close to a circle shape as possible. Okay, and this one you won't see quite as often, but it's an important concept to think about nonetheless. They're asking you to find the x and the y intercepts of this circle. Well, in order to do that, you could graph them and then just find it if it's at a point that it can be counted to. But in this case, our x-intercepts are not, they're going to be in between, not at what we call lattice points. So we need to solve it algebraically by plugging 0 in for y. And x-intercept means that our y-coordinate has to be 0. So when we do that, we plug 0 in for y, we can solve for our x. It ends up giving us a quadratic equation that can't be factored. So then I use my quadratic formula and simplify, and I end up with x-intercepts at 4 plus or minus 2 square root of 3. So remember, a circle could have as many as 2 x-intercepts. It could have as many as 2 y-intercepts. It could have no x-intercepts or no y-intercepts, or it could have exactly 1. Okay, so take a look at that. Take a look at some of the assigned work and see how that goes. And if you guys have any questions, I will be available on Thursday from noon to 1. And just shoot me an email and I'll send you an invitation if you'd like to attend. Thank you so much for your attention.